You know, August 4th might just seem like another regular summer day to most people. But if you look closely at the history books, it's basically a golden holiday for mathematics. Okay, let's dive right into this explainer and discover exactly why this specific date is so legendary.
It's honestly wild when you map it out. On this one single date, spread across completely different centuries and totally different countries, some of the most brilliant minds were either born or died. And the things they figured out, they literally built the world we live in today. Let's meet them.
Think about your favorite video game for a second. Have you ever actually wondered how it manages to render those buttery smooth 3D graphics in real time as you look around? Like, how does the in-game camera move so perfectly in every direction without just glitching out? Well, to find the answer to that, we have to rewind the clock all the way back to August 4th, 1805. That's the exact day a brilliant mathematician named William Rowan Hamilton was born. Hamilton's massive breakthrough was giving us something called quaternions. Now, I know that sounds like something out of a sci-fi movie, but it's basically a system of four-dimensional math. By using this super complex math to perfectly map 3D rotations, he laid the exact foundation that every modern game engine and flight simulator relies on today. He had this incredible aha moment where he realized that to make the math work, he needed to bend both space and time together. So yeah, every smooth turn you make in a virtual world, that is literally his 19th century math in action. But our journey on August 4th doesn't stop there. We're going to jump forward exactly 29 years on this timeline to 1834 to meet our next visionary. Before we do, consider this. How does a modern search engine instantly filter through millions or even billions of websites to find the exact piece of information you're looking for in a fraction of a second?
Once again, the answer brings us right back to August 4th, this time in the year 1834, marking the birth of the legendary logician John Venn.
Now, you've definitely seen his work. He created a highly visual way to represent overlapping sets and logic using overlapping circles. What's crazy is that this exact same logic, mapping unions and intersections, is what powers the search algorithms we use on our phones every single day.
It's kind of mind-blowing when you think about it.
Every internet search you've ever made is fundamentally built on his logic. His simple circles from the 1800s form the invisible architecture of our entire digital lives today. All right, let's keep this moving. We're sticking to our date, but we're fast-forwarding over a century. It's now August 4th, 1939. We're in a completely different country, and an even bigger idea is about to take shape. Have you ever wondered how doctors and scientists are able to use computers to predict incredibly complex biological mysteries? I mean, things like the exact rhythm of a heartbeat, or how a nerve impulse transmits through the body. That incredible, life-saving capability traces right back to August 4, 1939, with the birth of a pioneering mathematician named Brian Sleeman. Sleeman did something totally extraordinary for his time. He took rigid, complex mathematics and smashed it right into the messy, unpredictable world of biology. By using these intricate equations to model biological chaos, he gave us the very tools we use today to analyze heart physiology, nerve impulses, and even track tumor growth. He showed the world that the chaotic, seemingly random patterns of life itself can actually be mapped and understood. He was quite literally decoding the fractal complexity of life through the sheer power of equations. So one single date is tying together all these incredible leaps forward. Let's push ahead to one final foundational figure who, rather fittingly, passed away on this exact day. Think about the vast, complex software running our global banks, or the systems keeping airplanes in the sky. How do we actually know that the code isn't just going to collapse from a fatal logic bug? What gives us that foundational trust? Well, for that peace of mind, we owe a massive debt of gratitude to Gerhard Gentzen, a totally brilliant mind who passed away on August 4th, 1945. Gentzen developed entirely new systems of mathematical logic, specifically the N system and L system of predicate logic. Essentially, he did this to prove that our foundational arithmetic is completely consistent. And that rock-solid mathematical proof, it's the absolute bedrock of the safe, reliable computer programming we all rely on right now. His work literally proved that our foundational math makes sense. By reducing the huge question of consistency down to certain fundamental principles, he essentially secured the digital infrastructure of our entire modern world. No big deal, right? So, Take a step back and look at this. Every single person we've met in this explainer today, living across different centuries and countries, are all connected by August 4th. And you know what else? They were actually all asking the exact same question.
What is the pattern hiding inside the chaos? When you get right down to it, that is the ultimate mathematical wonder, isn't it?
Because they dared to look at the chaos and map it out, our world today has beautiful 3D games, instant search engines, reliable global software, and life-saving medical models. Math is quite literally everywhere, hiding in plain sight. So what hidden patterns will you discover today? Thank you so much for joining me, and I'll catch you in the next explainer.